Hello everyone, it's September the 1st. Alright, yesterday we tried a little bit JavaScript. It took a very long time. Man, it's pretty tough. So we have to go take a look how this one should be done. Other people's ideas. But man, it's not trivial. It's not trivial at all. I thought I know JavaScript. I know nothing. Seriously, I know nothing. Alright. What's this? Extra character in a string. We've done this before. Given a zero-indexed string, a dictionary, you have to break S into one or more non-overlapping substring, such that each substring is present in this. There may be some extra characters in S, which are not present in any of the substring. The minimum number of extra characters is left over if you break S up. So you break this up into these. So we break this. We don't even break it. LeetCode. Okay, so it's 50 here. Dictionary is 50 in length. There'll be something remaining. Okay. Do we build a try out of this? Maybe. Maybe we do build a try. So what do you think? Well, for everyone, you take a look into the dictionary. It's gonna be a try. So for everyone, you take a look here, and you see if it's not in it, then it's just it's not possible, right? I mean, like at the start, it's not possible. If it's possible, then for every letter, you always have a chance of either take it, right, or not take it. You can take it. So what we want to do is like DP, right? So we can say DPI is the minimum extra character starting from this towards the end. So we want to find out DP0, right? And to find out DP0, we can say take the first one and we'll do DP1, right? Whatever DP1 is, DP1 plus 1. Or we include this if it's inside, right? If it's inside. And we include this and then we start from here. Actually, we cannot start from here. Because it has to keep going. I mean, we can say we do one, right? But it has to be inside the dictionary, right? When you break up, it has to be inside. So if you want to start, you have to go, take the entire thing, and then you do the remaining. And if it can still go, you just keep going, right? Okay. Java can do that. Java can do that. So we need to implement a try in Java. Oh my god. How do you do try in Java? Class try node. Now you call it node. Each node, when you initialize it, it has value. So you make a character, letter, right? So we do character letter, and then we say this dot letter equal to letter. And we also need a hash map. character and will be a node. What do you call this? Map. And we say this dot map goes to a new hash map. And we have a Boolean value. What's this Boolean value? To indicate, right? Actually, no, there's no character. There's no this. You create a node. Oh, I did the other one too often, right? You create a node and you just, yeah, this is not necessary. We just create a node. We just create a node. Wait, isn't this how we do the? See, what's the difference? Wait, hold a second. Oh, because I didn't do this. End of word. End of word. Default is false. Okay, I think that is the node. So try is going to be a root. So we can say node root equals new node. All right. Then we say, let's call it try node. Okay, try node. Now we build this, we say for string word of dictionary for int I equal to 0, I smaller than word or length, I plus plus. And we also say, hold a second, try node equal to root, right? And then we say node dot map dot put if absent. Key is going to be word dot char@. Value should be a new try node. Alright, put if absent. Then node equal to node dot map dot get word dot @. So keep going once we're done. Node dot end of word equal to true. Yeah, this looks decent, right? This looks decent. Now in the DP function, it's like private int, right? DP int I index, and we need a memo. Memo. We can say integer memo, and we say this dot memo, the new integer. Well, each one will get some, alright? Each one will get some. So that's gonna be s dot length. Okay. So now we're gonna call this, right? And we say if, right, index is larger equal to string s, this dot s equal to s dot length turn 0. If memo index is not equal to null, return memo index. Otherwise, try node root. This dot root. Which way we don't even need to deal with this. It can just be root. Memo is also not necessary. S is required. Okay. So now, let's say option 1. Do not include make, not do not, make s index the extra character. So in this case, we can say int result shall equal to 1 plus dp index plus 1. Right? Option 2, try to fit s index into one of the dictionary, one of the word in the dictionary. Alright, so how are we gonna do that? We're just gonna match, right? We're gonna match. And we say for int I equal to index I smaller than s dot length I plus plus, right? Then we start from the root, right? We start from the root. We say try node root node equal to root. Then we say if node dot map dot contains key s dot charat I, right? If it contains, then node equal to node dot map dot get s dot charat. Else actually no. So we try it, right? The first one, is it in? Yes, it is in. Then node, move on to the next one. Then we say it is in. And node moved on to the next one. And every time when node move on to the next one, we shall check, right? If node dot end of word, if it's true, then rest shall equal to minimum math dot minimum rest dp I plus 1, right? The current one is included, right? This current one is in the dictionary. So as we've done that, we say break off, we do the dp, the I plus 1, right? And then we just keep going. In fact, this no, because if it's false, then we just break out, right? If it's false, we just break out. You know what? Maybe better we do this. Node equals to node.map.get or default is the char at I and no. Okay, so we do that, and every time we do it, we will do this. Right, it doesn't matter. Every time we do it, we'll say if node is not equal to null. Actually, it will be easier. Let's just say new try node. Then this is never null. But no. No. I like to do null. So if it's not in it, right? Or we can just say if node is equal to null, then we just break, because it's no way. Or we can put it here, I smaller than this and node is not equal to null. Yeah, then we don't have to worry about this. Alright, and then we say if it's not null, and if it's this, we try it. And then we try to keep going on the next one. Right, it'll become null, then we'll break out. Then we'll say, oh, sorry, I constantly remember this. I forget about this. It is not res. You can do memo index. And once we're done, we return memo index. Alright, we'll go through this one more time. This is right, and this is, we're not taking the current one, right? If we're not taking the current one, then yeah, that's fine. And this, if we start taking, then we have to take the entire thing, right? So we get a node from the root, and we try to get the next node, right? Once we get the next node, we check. If it's end of the word, then we run it, right? We run it. So the current is fine. Then we just run the next one, right? We'll run the next one because the current one is fitting, so there's no extra. So it's just be from I plus 1. It's the next one. And each time we hit an end of word, we'll run it, right? Each time we hit it, we'll run it. Each time we hit it, we run it until we exhaust and it become null, right? And we get out. Okay. So I like to have all these things set up at the beginning, and we here can do just return dp0. All right, let's give this a shot. Does it work? It does work. All right, that's I know it's distinct. Okay, so this is a true. What's with this? Oh, it should be, both should be true. Should be 0. Right? Alright, let's give it a shot. Oh! Wait a second. Wait a second. I did this a month ago. Huh. A month ago. I didn't even remember. I did not even remember. I completely forgot about this. Well. Use try to convert dictionary into something easier to check. Then DP, in which DPI is the minimum extra character in S needed in SI towards the end. For each I, we can choose to make it extra or try to match SI towards the end in the try. Oh, what's the runtime on this? I call M is the entire length of this. This is OM. So O K M plus NM, where K is the length of dictionary, N is length of S, and M is the average length of word in dictionary. Right, because this will go through n states, but for each state you have to go through this. Oh, in fact, for each state you have to go through, so actually this is ON squared. If we're talking about worst case, right? In the worst case, you have to traverse the entire thing if everything fits, right? So I actually just say this is fine. This is ON squared. Okay. Substring method. Start to end. Yes. If it contains. Yes. Try. Try node. Oh. Oh wow, so I don't even need this. Did not know that. Just need to say hash map, and let's make it explicit. Nice, this is good enough. Uh-huh. I mean, they both work, right? Put if absent. Did you do put if absent? I did put if absent. Yeah. I think it's pretty straightforward. Unsquared MK. Ah, yeah. This is a true, medium question. Cheeky. Yes, this is a medium problem. Okay, so we're done with this. Good. Let's copy the answer. Yeah, surprised I did it a month ago. I don't need this one. Alright, so we're done with this. Now we have to go back to this and then check. Beginner friendly, come on, show me. I need beginner friendly. In JavaScript, instance is achieved with a prototype chain. We can get a prototype of an object, yes. This compare class prototype with object prototype. We will traverse the entire prototype chain until we find a match or else return false. Okay. Well, object is not null. What if it's undefined? If it's equal to, return true. Otherwise, object. So we get the prototype of the object. And we find its constructor. Huh. Yeah, you can have this, right? Get a prototype. This could be undefined. I like this. Wait, hold a second. The prototype is equal to that prototype. That's it? What if you need to recursion? You're not doing recursion on this one. What if you have inheritance, like heavily inherited? Yeah. What if you have like heavily inherit on this one? What is this gonna work? I have no idea. You wanna try? Okay, let's comment out this. Right, okay, so let's say class foo. Okay, class foo extends foo. It works, right? And class foo 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 extends foo 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 foo. Alright, we'll just console.log. I just want to see. Let's say foo.prototype. Right? Node. Oh, that's not right. You can't define this way. So you're telling me it has to be a class. Wait, how do you define a class? Class, construct. I don't need constructor. I just want the Oh, you have to define the method that way. You can do static. Inheritance. Speak. Speak. Okay, so we have to do right, I think that's what it's trying to do, yeah. So this has to be foo foo. This has to be foo foo foo. Okay. Does this work? So foo prototype, it doesn't have anything. This has something and this has something. It's weird. The prototype is really? That is not what I know. That is not what I expect. Constructor and the foo, right? This is what I expect. It's supposed to be foo. I mean, I don't really do a constructor. And if I do foo foo without prototype, yeah, this is what. Oh, it's prototype. Its prototype is foo with constructor and foo foo. I think I got confused again. Foo's prototype is just this. Foo's prototype is foo. So when you extend, it goes into your prototype. Hold a second. Inheritance. I just read this yesterday and I have to read it again. Child is an object that inherits. Oh yeah, this prototype is its child, is its parent. I have this box. Its prototype is a constructor and a get value, right? If you inherit from this box, then your prototype becomes the box. The extends basically means we set its prototype to base its prototype, right? So when this one extends full, it just means its prototype equals to full's prototype. Mm-hmm. Prototype is going to be, and I have another prototype. It's prototype's prototype. Extends, okay? These are not in the prototype. So this, its prototype is this is prototype. And this is prototype points to this is prototype. And its prototype points to the object's prototype. And object's prototype points to no. So with that in mind, all I want to see is full's prototype shall equal to full's prototype. It's not what I see, right? No, I think what it means is full's prototype. it's full's prototype's prototype is full's prototype, which means it's prototype's prototype. Well, I mean, it doesn't have prototype, so it's gonna be proto is equal to full's prototype. This is correct. This is correct. So, in that case, right? In that case, in that case, if I create, actually I have one more layer, right? I have one more layer. Then we say inst foo equal to new foo. Then inst foo proto. What is this? Its prototype shall be foo's prototype. Right? This prototype is foo's prototype. And this one just says that's so we can do, let's say right, say new foo class function foo. It's true. Ooh, really? Well, it's prototype. Oh, it's a recursion. Oh, not recursion. It just keeps going. So we get the class's prototype. Okay, we get the class's prototype. Whatever it is, we get the class's prototype. Whoever it is, and then we get the object, right? And then we get the object's prototype. Fine. And if the object's prototype and the class prototype is the same, then it's fine. If it's not the same, I do it again. So this is the chain. This is where the chain happens. This is where the chain happens. So this is basically the new object. This object is the object's prototype. And then if it's not the same, then we get the prototype's prototype. And the prototype, so one of the prototype, if they're equal, then we're good. Holy. Oh, it works. Solution from so prototype means your prototype's prototype. Okay, class function or class called the prototype. It's prototype, and then this prototype is an object, and you call get prototype off, right? So a class's prototype. A class's prototype, right? We have its prototype, and its prototype's prototype is its parent's prototype. Yeah, so if this is one level, so you need to keep going. You need to keep going. You can't just compare the constructor. This is good. All right. get the class functions prototype. Then traverse the prototype chain of the object. Whenever whenever one level of prototype in the chain matches the class functions prototype, we have a match. We have an instance of match. And this class function could be something inherited, so it has its prototype, right? Basically, its prototype is pointing to some other class, right? Some class. And then your object's prototype is going to be something's prototype, right? And then its prototype will be, yeah, this works. This works big time. This is too complicated. All right, need more practice. Need more practice of JavaScript. It is hard because I'm not used to it. All right, I have this array prototype last. Write code that enhances all arrays such that you can call array.last method on any array and it will return the last element. If there are no elements in the array, it should return -1. You may assume array is the output of JSON parse. Oh, I directly do the prototype for all the arrays. Okay, I do the prototype of all the arrays. So what do? We will do we'll do this. How do we get the last value? I do not know. Let me see something. Okay. If we call nums.proto, what do we get? We got a constructor. We get all of these functions. And these are array, right? How? Oh, I can call. Can we call array? How do you access? How do you access the? That's a good question. I have no idea. How do you access? Or I mean, it's nums dot something. I don't know. how to access. Okay, access array from array.prototype. Okay, let's see. This yes, this. We use this. Okay, so I think we use this. In fact, I don't want to try it here. Let's do it this. So I will use this. Okay, so we say, can we call this dot length? I think I can. If this dot length is, I think it's this, right? I'm not sure. I'm not sure. I think it's is a function or, dude, nums dot length. No, it's not a function. It's a property. If this is equal to 0, right, then we return -1. Otherwise, so I return this, this dot length -1. Okay, let's give it a shot. Oh, I think it works. Yes, you use this. Why? Because this is the thing that binds, right? This, yeah, because this is array. That's the overall object. And then nums is an instance of this overall object. And when this instance is created, it have a this, which is binding to this instance. And then if we call anything from the prototype, you need to find where this comes from. And this comes from the instance. That's why this is correct. Nice. Oh, I solved this one. Nah, it's not enough. Man, JavaScript's weird. It's just, I don't know, just weird. Whole thing is weird. I mean, a long time ago, I read a book, not completed. I think it's called. I have it here. Eloquent JavaScript. And back then, I think that was when I first started. Very tough, very tough. I think I got this the whole promise chapter, like resolve promise, got me so confused, and I need to use some analogy. I remember the analogy I have is chef cooking. Now you get the order, right? You get the order is when you call the promise, and order goes in, but you have to wait. You wait for the promises. You wait for the chef to finish cooking, like that whole stuff. And then I kind of don't like it. And then now coming back. It's, yeah, this is a learning process. Use this to access an instance of array. All right, let's hope other people have the same idea. Level up your JavaScript skill. Nice. This is exactly the same as mine. The hell is this? Global. Oh no, this is a TypeScript, right? This is for the type. Implementation 2. Okay, that's fine. It's all right. What is this? This dot slice. Slice the last one. Yeah. Okay, so this one good. Let's try another one. How do we try another one? Do we just go next? Problems. Oh no, that's not the way to go. I need a specific JavaScript. Okay, so we done these. We have counter. Let's just do sleep. Yeah, we just. Oh, debounce. Holy crap. Deep equal. Damn. Curry. Oh, curry is premium. Man, this could be something needed. I did some counter. Hard as all premium. Yeah, I need this to prepare for an interview, so. And none of these are open. Oh my goodness. My goodness. That's okay. That is okay. That is totally okay. That's enough practice. Enough practice for me. Alright, what's this counter? Given an n, return a counter function. Okay, it's a function. This counter function initially returns n, and then returns one more than the previous value every subsequent time it is called. So, initial value. Wait, how do I save the initial value? The first time called. Huh? Wait. Oh, create counter. Oh, okay. So use this. This is 20. Use the keyword this to bind it. I can say this dot n equal to n, right? I think I can. This is fine. All right. Oh my goodness. It's a function. I can call constructor on the function, right? Or can I not call construction on function? I think I saw this example function. Yes, I can. This is just its attributes, right? Its attributes. Okay, so I do that, and I need to return a function. Like this is a create counter. This return function is the counter itself, and every time we call it, then this needs to. So I can say const res equal to this dot n, and every time I call it, say this dot n plus. Do they have plus plus? Not sure, and then return res. Okay, does this one work? Man, I just feel. Oh, I think this is right. It's weird. It feels like, you can do whatever you want. That's what I feel. A closure. Function has a reference to all variable declared in the same scope as well as any outer scope. Yes. Yeah, because this A is in outer scope. Oh, holy crap. Oh no, I have to create because I need to increment it. Yes, I recognize that, but what if I just need to create a counter, this dot count, number of time it's been done, so to 0. Then we simply say this dot count plus n, this dot count, and then return. Something like this. I think this one shall work as well. Or I can do it this way. Then we return this dot count plus n. Yes. Yes. This feels a little bit better. Okay, this is closure. Oh, and I don't need to call this. I can just call a let. Right, because closure. Man, this is probably one of the best way to learn JavaScript. Oh. Oh, you can't. Oh, what if we do this? Count equals -1. Now you're in the scope. Nope. Huh? Nope. Oh, we can do this. Nope. We can't make changes to this thing. It's interesting. Huh. Didn't work. Has to use this. Thought closure will work. I mean, closure is, you are using closure. This n has been putting below. Oh my goodness. Yeah, it works. So this way works. But it's faster. Use closure, where the argument of create counter is memorized by the return function. Let's try the other one. I don't think the other one will work, honestly, because that would be too weird if you can do it this way. Depends if it's No way. No way. It's a variable. You can modify it. Holy moly. Ha. Ah. 4 different ways. Closure allows for true encapsulation. Yes, you can change it however you want. I think this is what I read earlier. I think it's here. Hit this. Private field. Private field. Yeah, this is private field. Yes. Each instance stored a single reference to yes, because they're instances of the class. So the class's prototype do not get recreated for each instance. You just need one of them. It's like you're one of them. It's in the, you have a pointer, right? And you can always point back to that. But if it's closure, then each one creates its own copy. Multi-paradigm. This means it's very loose. Increment, then return. You can. I tried that. It didn't work. Didn't we try that? Dude, I think I tried that and did not work. I mean, you use, I use let. Now it works. I have no idea. I tried this earlier and it didn't work. Well, I do agree. This is maybe we can do this plus count. You want to entertain this idea? Oh yeah, yeah. All right, this is we find the optimum. This is the optimum. Nothing beats this one. This is the best. Holy crap, this is the best. I forgot a plus and then, oh my god, yes, this is the best. Because this returns n and then increment. Holy moly. Talking about, oh. 6 different POSIX, yes, this is the best. No, it's not. I don't think it's like easy. I mean, especially if you're like me trying to learn JavaScript from like again. These are interesting concept. The closure, right? The closure is always an interesting concept. This is the ultimate. This is not even the ultimate. This is the ultimate. All right. This is the ultimate. Doesn't mean it's fast or anything, but it is. Yeah, you start to feel it, right? You start to feel it. You start to feel it. You want to do this? All right, let's do this last one. Okay, last one for today. A part integer millisecond. Write an asynchronous function that sleeps for this. It can resolve any value. So output. So what do we do? Sleep dot let t wait, hold a second. What? It shall return a promise that resolves after 100. Oh, this is the function you call. Oh. Oh, you get a current time, and then you call this function, and when you resolve, it shall become this. All right. What do you think? I don't know. I don't know. I don't even know what to think. These are great questions. My God. Okay, so because it's already async function, so that's fine. So we can sleep. Wait, what's the sleep? Oh my God, I forgot. I think that. What's the sleep? Dude. JavaScript sleep. I wrote a sleep before. I don't recall. Ha! I have a no, don't do it that way. Oh, what's that? Well, it's not sleep. It's what? It's set timeout. Set timeout. Yeah, you see, I was, see, I was learning about it before. Set timeout. So basically, we want to set timeout inside, right? How does set timeout work? Set timeout, you have a function, then you call set timeout. And you return something. I mean, it's async function, it's already returning a promise, right? And then you need to set timeout of this milliseconds. And after that happens, you do something, and then you return. Honestly, I don't know. Because I remember the way I did in one of my tests. It was not right. It's, it's just stupid. Yeah, how do you create this? Because you need to resolve, right? So you can say but set timeouts. Actually, I don't know. Let me see the hints. It's set timeout. Yeah, a function. So how do we do this? Because this is just a function call, right? This is just a function call. Yes, what's the last one? New promise. You want the function to return a value. Okay. You can code a new promise when you want the function to return a value. Code resolve value inside. So when it resolves, are you telling me that when it resolves, it has to call the set timeout? Or after set timeout, we resolve? After set timeout, we resolve. So what if we do return a promise, okay? And we have resolve and reject. And it's the resolve, because we need to resolve the value, but we'll wait to resolve it. So we can say set timeout, okay? Resolve foo, doesn't matter, wait milliseconds. That's resolve. And we don't reject. Nothing is rejected. Is this right? You resolve inside set timeout. Undefined is not a promise because undefined is not a promise. Dot then, which is to call the resolve. I don't know. Let me read this one. One more time. Oh, a new promise. A new promise. Has to be a new promise. Nah, it's not right. Yeah, I already saw a solution. What's this? A new promise, a resolve. So you return a promise, right? Which the promise has a resolve. You call the resolve, but the resolve cannot be called. Yeah, because the then, right? The then will call the resolve to give whatever value it is. Right? You call then to call the resolve, but this resolve function cannot be called until the set timeout is done. Yeah, this one is more. I can try it out, but busy waiting. What's this? This is just. Let's don't get too deep into this. So we return a new promise. Then we need to resolve. Yeah, because we don't have reject, so we don't have to do reject. And then we'll set timeout, right? And then we do the resolve inside. How? Wait, hold on. Isn't that the exact same as this one? Resolve. Set timeout, put the resolve inside. Yeah. What did I do? I resolve. I resolve full. How are the two different? You said I can resolve to anything. That's why I resolve. I don't understand. Why I cannot resolve things. I have to just put resolve there. Are you telling me by doing this you resolve immediately? I think that's what it means. You resolve immediately. Promise or resolve. Because the resolve outer is called synchronously, but it is resolved with another promise, won't be fulfilled until 1 second later. In the resolve fulfills. Hey, this is exactly my thing. this shall resolve immediately, right? Let me try this one. Actually, no. Yep, it's immediately resolved. Because this is resolved synchronously. But that's not what I expect. I expect this to... Oh, it's different. Hold a second. It's a function. Yeah. Now we're pending. Huh? I don't... Now it comes out. I don't understand. This we have a delay. So what's the difference between this and this? Well, the difference is this we have a function to call resolve. In my case, I just call resolve immediately. What? Refuse to evaluate. I can't even do this. Huh. Alright. But anyway, right? When you call then, hold on. What happened when you call then? When you call the then method takes up two, right? Callback for the fulfilled case, the second callback. So when you call then, you're waiting for resolve to be called, right? You're waiting for resolve to be called, and the resolve is not called until this. But In this case, this is not allowed for whatever reason, which means, yeah, this basically they say this is not going to work. So what if we put this into a function? Does this work? Now it works. So what I think, I mean, it's not allowed in the browser, it's just a rule, right? But the general case is true. The then will execute, this function, right? This function will execute whenever resolve is called. And resolve will be called when set timeout is called. Yeah, it makes sense. It makes sense now. If I don't do this, right? If I don't do this, I'm calling resolve immediately, right? You call the sleep, and then this function gets called immediately. And whenever resolve is called immediately, this callback gets called. So that's why this is wrong, right? There's basically no delay. But if I do this, right, then there's no function call, okay? There's no function call. This is a function, right? So what happens, you call then you're waiting for the resolve to be called. But the resolve will not be called until this function gets called. And this function is not called until set timeout is timeout. And then you call resolve. Makes sense. Now let's go back to this. This is just put resolve, right? It's not a function call. It's not anything. It's just resolved by itself. Because this is a function. It's not a function call. So this one's correct. Gotcha. I think this one will be more intuitive for me. Okay. Now we can submit this. That's correct. Yeah, of course it's correct. We know what this one is. Okay, so I'm gonna end right here. You know what? One more thing. Let's take a look. The sleep function takes a positive integer and then creates a promise. Yeah, you can wait. What? Why you will wait? The resolve after milliseconds. The promise is then awaited using the await. Await. Yes, you're guaranteed to return a promise. So basically, this is return null, right? So this method, it's return null. It's not returning anything, but the waiting happens here, okay? The waiting happens here. It does not happen here. So when you call sleep 100, it waits here. And when this wait is done, then this does not wait. When you do the return, it waits here. So that's kind of the difference. Promise allows code to continue execution while you wait for another action to complete. because set timeout itself is not a promise. It's not async. It's not a promise. Either wrap A in a promise and use that then. I think both. Yeah. All right. It is good. This is very good. I think it helps. I'm even thinking maybe in the interview this will be the question. Please write a function that can implement sleep, right? So then we can do that. We can do that. Okay, that will be it. Oh my goodness, what is? I'll deal with this tomorrow.